Naming compound. In naming compound, we first have to identify two vocabulary that we need to know. One is the elements and one is the compound. And elements are substances that are composed of atoms that have the same atomic number. Element cannot be broken further down by chemical change. While a compound is a substance composed of two or more different elements that are chemically combined in a fixed proportion. So a compound can only be broken down by chemical means. Now, the naming of compound is based off of UPAC, which is the International Union of Pure and Applied Chemistry. So there can be 5 rules we're going to learn, and we need to identify which rule to use. So first of all, we need to identify the elements, and then we have to determine how many elements there are. If we have 3 or more elements, then we need to use the polyatomic ion table, which is table E. Then we're going to classify the elements. Are they metal, non-metal, transition metal, and so forth. And then that way we know which rule to follow. So in rule number 1, we are dealing with metals and non-metals. So for the metal, we're going to keep the element name. The non-metal, we're going to add the IDE to the roots of the elements. And then let's take a look at this. So for example, in NABR, we see that we have 2 elements, and the way we can tell that they are elements is that they begin with a capital letter. So we have 2 capital letters, so 2 elements. So the first element is Na, that is our metal, and Br is our non-metal. So Na is sodium, so we're going to write down sodium. And Br is bromine. Remember that we're going to only keep the root, which is brom, and we're going to add in IDE. So that becomes sodium bromide. Note that the metal go before the non-metal. In rule number 2, we are looking at metal and polyatomic ion, which means that we have more than 2 elements. In this case, we're again going to keep the element names of metal, and the polyatomic ion, we're going to keep its name also. And to determine the polyatomic ion, we're going to go to table E, which will be provided for us. So let's just take a look at this example. In here, we have 3 capital letters, so that means that's 3 elements, Li, En, and O. So first, our metal is Li, so that is lithium. Now, NO2, we're going to go to the polyatomic ion table, and we see that NO2 is actually right here, NO2, nitrite. So we're going to write down nitrite. So this compound is therefore lithium nitrite. So let's take a look at rule number 3. This is between transition metal and non-metal. And transition metal, reminder, is group 3 to group 12. In the transition metal, we keep the same element number, but we use the oxidation number as the Roman numeral. For the non-metal, we still keep the roots and we add IDE. So let's take an example of FeO. First of all, we know that Fe is iron. And I'm going to open a parenthesis and leave it there because I don't know what the oxidation number is yet. And we know that oxygen is oxide because we drop the N and we put an IDE. So how do we determine what goes in this blank? So let's go take a look at the oxidation number for oxygen and iron. So oxygen has a -2 charge. So we're going to write -2 up here. So we know that there is a 1-to-1 relationship between Fe and O, then therefore Fe must also have a +2 charge. Okay, so therefore this is a +2 charge. So if that's a positive 2 charge, then what we're going to write down is 2 right here. So therefore the name of this compound is iron 2 oxide. In rule number 4, we are now dealing with transition metal and polyatomic ions. Again, the transition metal keep the element name and we add the oxidation number as Roman numeral, and the polyatomic ion we get from the table E and we keep the name as is. So let's take a look at the example, Fe2SO4 3. So we know that Fe is our transition metal and the SO4 is going to be our polyatomic ion. So let's start writing this. So iron, remember to leave the parenthesis. And then SO4, we look over here and we see that SO4 is sulfate. Okay, so we're going to write down sulfate. Now to determine what to write into this parenthesis, we have to identify the oxidation number of iron. Now when the two sets of elements are not in a one-to-one relationship, so in this case there's 2 Fe for every 3 SO4, it's a very easy way to find out what the charge of the transition metal is. All we have to do is move the 3 up to here and move the 2 up to here. What we're doing is a backward crisscross. Okay, so that tells us then that the Fe is a positive 3 charge, and that the SO4 is a negative 2 charge. Okay, so therefore we can write 3 right here. So rule number 5 deal with nonmetal. So in the first nonmetal we keep the element name, and in the second one we keep the root and add the IDE. What's unique about the nonmetal is that we use the prefixes to indicate how many atoms of each of these elements we have. So let's take a look at SO. So here we have sulfur and oxygen. So first, to make this easy, we're just going to write down sulfur and oxygen. So as we already talked about, we're going to change oxygen to become oxide. Okay. Now, remember that we have to identify the number of atoms. So we have 1 sulfur and 1 oxygen. So that's the prefixes mono. Okay. So, but remember that the rules say that if the first element is have a prefix of mono, we don't need it. So we're gonna not put mono in front of here, but we're gonna put mono in front of oxygen. So let's rewrite this. So we have sulfur, and then we have monoxide. Now, remember that according to the rules, if the oxygen is the last element and any of the prefixes has the O or the A as the ending, we will drop that ending. So in this case, mono in with an O. So we're going to drop that O. So therefore, we're going to rewrite this as sulfur monoxide. O, going to drop that O. And so our compound name for this is sulfur monoxide.